right, let's just jump right in. You know, if you've ever worked with spatial data, I'm almost certain you've hit this exact wall. You have a mountain of information and you need to understand it like yesterday. But which tool do you grab? Well, that's exactly what we're going to break down.
So just picture this for a second. You've got 50 million spatial data points on your hands. 50 million. We're talking LiDAR scans, IoT sensor readings, GPS coordinates, the whole shebang. And they're just sitting there, waiting for you to find the insights. So here's the real question, right? How quickly can you run a pretty simple aggregation on all that data? Let's say you just want to find the average elevation for different point classifications. What's your gut feeling? How long should that take on, say, your average laptop? Okay, so this is where things get kind of wild. Using PostGIS, which is an absolute rock-solid industry standard, that query takes about 45 seconds. Not too shabby. But with DuckDB, it takes just 3 seconds. That is a 15 times speed up. And look, this isn't some kind of black magic. It's all about a fundamental difference in architecture, and it's really the key to understanding how to build modern data systems the right way.
Reaching for PostGIS for this specific kind of analytical job is a bit like this. I mean, sure, you can do it. It'll probably work eventually, but it's not what the tool was built for. And that's the whole point of this explainer. It's not about which tool is better. It's about picking the right tool for the job.
So let's pull back the curtain and figure out why that massive performance gap exists. It all starts with a mistake that honestly is super common in the world of data engineering. And there it is, right there. It's the classic one-size-fits-all trap. We all do it. We find a tool we love, like PostGIS, we get really good at it, and then we try to make it do everything. But as we just saw, that can lead to some serious performance headaches when what we need to do shifts from just serving data to actually analyzing it. Okay, to really get why, we've got to pop the hood. That speed difference we saw, it's not an accident. It's totally by design. It all boils down to this fundamental split in the way databases are actually built from the ground up. So on one side of the ring, you've got OLTP, which stands for Online Transaction Processing. Think of this as the engine of your live application. It's built for thousands, even millions of tiny rapid-fire operations. Fetching one user's profile, updating an order status, saving a new GPS point. It's all about speed and handling lots of users doing small things at once. Now, OLTP systems usually do this using row-based storage. The best way to think about this is like a patient's medical file. If you need to know the patient's name, you have to grab the entire folder, right? You get all their info at once, and that's super, super efficient when you need that whole record, which is exactly what an API call usually does. And then on the other side of the ring, we have OLAP, Online Analytical Processing. This is a whole different beast. It's not interesting in one little record. It's about asking those huge, sweeping questions across millions of records to spot a trend, or calculate an average, or build a big report. This is the world of pure analytics. And OLAP engines have this secret weapon, column-based storage. Just picture a massive spreadsheet. If you want to get the average of everything in column C, you just read column C. You completely ignore A, B, D, all the others. And that is exactly why it's so ridiculously fast for our 50 million point problem. It only had to read 2 columns out of the whole data set. All right, so we've got the theory down, right? OLTP versus OLAP, transactional versus analytical. Now let's bring our 2 contenders into the spotlight because they are basically the poster children for each of these approaches.
In this corner, we have PostGIS. I mean, it is the undisputed heavyweight champion of transactional spatial data. It's the spatial extension for Postgres, it's been around for over 20 years, and it's designed to be the bulletproof backbone of your application, handling tons of users all reading and writing at the same time without ever corrupting your data.
And in the other corner, the scrappy challenger, DuckDB. It's basically the definition of a modern, lightweight OLAP engine. You don't set up a server, you just pip install DuckDB. Its superpower is just incredible. It can read massive data files like Parquet directly, even from the cloud, and run huge analytical queries on them in seconds. It's built for one thing, crunching big data, really, really fast. And when you put them side by side like this, it all just clicks, doesn't it? Look at BestAt, API serving versus aggregations, or the performance rows. PostGIS is microsecond fast for one row, but DuckDB crushes the big aggregation. They're not even in the same weight class because they're not fighting in the same sport. They're specialists.
So with all that, how on earth do you choose? Well, here's the cool part about modern data architecture. You don't. You don't have to choose.
This is the question that got us here in the first place, right? PostGIS or DuckDB? Which one is it going to be?
And the answer is both. It's not a competition. It's a collaboration, a partnership. You use both of them together.
So check this out. This is how the modern stack works. PostGIS, it runs your application. It's perfect for managing users, project metadata, and serving those lightning-fast API calls for single records. Your massive raw data? Let it live as super efficient Parquet files in cheap cloud storage like S3. And then, when you need answers for a dashboard, an ETL pipeline, whatever, boom. DuckDB swoops in, reads that Parquet data directly, and gets you answers in seconds. Each tool is doing exactly what it was designed to do best.
Okay, let's bring this home and make it super practical. How do you decide for any given task which tool to pull out of the toolbox? So here's your cheat sheet, your simple go-to guide. Are you building a live web API with lots of users? That's PostGIS, all day long. Are you trying to scan millions of rows from a file to compute some stats? That's a job for DuckDB. The big question you always have to ask yourself is this: is my task transactional or is it analytical? Your answer tells you exactly which tool to grab.
And that right there is the big takeaway from all of this. We have to stop asking which one is faster and start asking which one was built for this exact problem. PostGIS isn't slow. It's an insanely fast transactional database. DuckDB isn't magically better. It's a purpose-built analytical engine. They just solve different problems. So the real shift in thinking here is to stop looking for the one single best tool and start designing the best stack. You know, the best architects don't have one favorite hammer. They have a whole toolbox, and they know exactly which tool to pull out for which job. So that leaves one last question for you. What's in your toolbox?
If you found this helpful, hit subscribe and the bell so you never miss a video.